In this first session of AI series, we'll be covering large language models. LLMs, in short, have been popular terms since the advent of services like ChatGPT. With advancement in generative AI, many big companies have been spending resources in building their own LLMs. So let's have an easy yet better look into what they actually are. So what LLMs are? Large language models are trained AI models using deep learning to understand the synergy and context of characters working together to form legible text. LLMs are a kind of foundation models. Foundation models are primarily deep learning neural networks, which are more general purpose and which can be used to develop ML models further to be specialized in a cost effective way instead of training a new model from scratch every time. They are focused to recognize and generate primarily text, and code being a kind of text. There are some models specialized to recognize and generate code as well. These models can be turned to any specialized form, language, or usage context of texts when being trained on relevant training text. OpenAI's GPT-3, GPT-4, Facebook's Llama 3, Google's Gemini, Minstrel are few examples that can be used to try the LLM capabilities. There are tools like Ollama that can be used to easily try them on local machines without the need of any internet-based paid API. Now on how LLMs work. Currently LLMs popularly use transformer architecture that is based on a paper attention is all you need. LLMs use unsupervised training with transformer providing self-learning. Initially, sequence transaction models used for this purpose were like RNNs, CNNs in encoder-decoder configuration connected with attention mechanism. With new research, the RNNs, CNNs have been disposed of using self-attention alone with encoder-decoder. This has reduced the training time by a lot. LLMs gain the capability to predict next word to the input they receive, utilizing patterns they have gained using training parameters on continuation of enormous amount of data tokens it has been provided. Since it's biased with all these patterns, it's still vulnerable to things like hallucinations. That is, it generating untrue responses because the continuation of text fits the parameter. Some popular use cases for this are general text generation, aiding in finding answers to queries from huge chunk of data or entire history of things. Content summarization, as it's able to gather context of available text to extract crux of it. AI assistants, with the capability to map input queries to relevant responses. Code generation, as code is just text with special grammar, and more. We'll be covering more on this in later sessions. That's it.